this question was taken from the Pure Mathematics 1, Paper 1, 6th of June 2018 booklet. A curve C has equation as shown here, where x is greater than 0. In part A, you're required to find the first derivative and the second derivative. You also need to verify that at C, verify that C has a stationary point when x equals 4. So now let's write the equation of the curve in the form y equals x squared minus 2x minus 24. Instead of having root x, I'm going to have x to the 1/2. And we can now find the first derivative. So dy by dx. This would be 2x when we differentiate x squared. We get a constant there, 2. And that would be minus 12x to the minus 1/2. Okay? Now, we want to now verify that it has stationary point when x equals 4. So when x equals 4, so at stationary point you need to know that dy by dx equals 0. Yeah. So so when x equals 4, we should get 0. So what we need to write first is at stationary point, at stationary, dy by dx equals 0. So if we input x equals 4 in here, we should get 0. So dy by dx, we're going to have 2 times x, which is 4, times 4, minus 2, minus 12. Instead of having minus x to the 1/2, I'm going to have 1 over x, which is 4, the root of 4. Okay, it's the same thing. Okay, now that would give us 8 minus 2. Root of 4 is 2. So 2 into 12 is going to give us 6. And that gives us 0. Therefore, C has stationary point at x equals 4, because we get 0 for it. Okay, so we have given the reason for our answer. Let's move on to part 2 now. We want to find the second derivative. So let's write the first derivative here first, dy by dx. We got 2x minus 2, and that's minus 12 to the minus 1/2. 12x to the minus 1/2. So the second derivative then, when you differentiate this, we're going to get 2. That becomes 0. This would become positive 6 x to the minus 3 over 2. Okay, so let us write, I'm going to write this as the root of x cubed. So what we're going to have is 2 plus 6, and and then the minus is going to be 1 over the root of x cubed, all cubed. Okay, so when x equals 4, when we input the value of x in here, if we get the second derivative, great, let me write it here. When the second derivative, whatever value we get, if it's greater than 0, it's minimum value. If it's less than 0, we would have a maximum point. So these are things that you should know, okay? So let's just put that aside there so that you know. So when we input the value of x in here, if we get a value greater than 0, the curve would have a minimum value. And if we input it and get something less than 0, we would have max. Let's write 0 here. So let's see what we would get then. So second derivative then, when x equals 4, we would have 2 plus 6 times 1 over root of 4 cubed. So that would give us 2 plus 6. The root of 4 is 2. 2 cubed is 8. So it's 1 over 8 there. Okay. And that gives us 22 over 8. So that's greater than 0. So what we get there is 11 over 4. So since the second derivative is greater than 0, the curve has minimum. So we just need to say since equals 11 over 4, C, the curve C, let me just write, the curve C has minimum value. The curve C has minimum value. Our minimum point. Here ends question 2.